Hello again. In this video we will talk about sketch blocks. Let's start a sketch on the front and then draw a corner rectangle and give it the following dimensions. Then draw a circle inside, something like this, and set it to be tangent to this line and tangent to this one. Then let it be 30. Let's assume that you are going to use this a lot in your design. In this case, we need to save this shape so we can call it whenever we need it, instead of sketching it from the scratch every time we need it. That's why we will create something we call block. To do so, right-click anywhere in the ribbon area and select blocks. Now you will have this toolbar. You can keep it here, or you can simply drag it and place it here. Now let's select Make Block. Here we have this dialog box and it asks us to define the block entities. In this case, we will select all these entities. Before doing so, let's talk about the selection. If you start from the right to the left, as you can see, I didn't select the whole circle, just part of it. But still, if you start here and go to the left, even if you just select a small part of it, it will be selected. Let's clear this. Now let's do the opposite. Let me start from the left to the right. And here I only got this one because it's the only member that was totally selected. So this is the difference between selecting from the right to the left or from the left to the right. So for now, I will select the whole thing. And here you have all these entities. And then you can control the insertion point. This is the default insertion point. If you're not happy with it, just click, hold, and drag it to whenever you want. I will snap to the center point of this circle. Then I will release and then hit OK. Now, if you look at the model tree, you will find block 1. Now, you can right-click this block, and here we have many options, like Edit Block, Save, Make Block, or Explode Block. We will talk about them in detail. For now, let's talk about this. Rename Tree Item. You can rename this block to call it A1, for example. Then click anywhere, and here you have the new name. Now, if you will use this block in this drawing, you can simply select Insert Block. And here you have another one, and another one. Once done, hit OK. Let's say that you will use it with another file, not only with this one. In this case, you will need to save this block and just call it whenever you want it. To do so, you can simply select Save Sketch as Block. Now, you can navigate to any folder you want, and you can place this block. And whenever you need it, you can call it, and we will see how. And don't forget that you can give it a better name here. Let's say A2. So what happened? Now we had a name here, and it asked us to define another name. The name we defined here will only be used here. But whenever you need to call the block, you will use the other name. I'll show you how. If I create another part and start a sketch here, let's say I want to call that block now, since I have another file. In this case, select Insert Block, Browse, and you can navigate to the folder you placed your block in. And here you will find the block with the second name you created. Once again, select Insert Block, and here you have two blocks. The first one is still saved in the memory of SolidWorks, and the other one is saved externally. If you select A1, you will only have this block. If you select block A2, you will have the whole sketch. Finish this sketch and go to Window and go to the first part we created. As you can tell, all these four were saved as one block. Let's say you want to save one of these externally. Only one, not the four. In this case, select any of these here, then select Save Block. And now give it another name, let's say A3. And I need to call it. So insert block, browse, navigate to the folder, and then select the block. And here I only have one block of this. So this is how you create a block, and this is how you save it and you call it. In some cases, you will need to modify an existing block. To do so, select any of these blocks, right-click, and you will find Edit Block. Then you can edit these dimensions. Once done, you can finish the editing process from here. Now, this block has different dimensions, and as you can see, all the copies of the same block were modified. Let's say you don't need this to be a block anymore. You need to deal with these elements separately. In this case, you need to right-click this block and you select Explode Block. Now, this is no longer a one unit. You can deal with it as regular sketch entities. Dealing with the blocks makes it easier to deal with the sketch. Like imagine if you need to move this part. You will need to select Move Entities, or simply you need to define a lot of dimensions and relations so you can move it as one unit. And if you have any mistake, you will have a different shape. But in this case, you deal with this as one unit. This is what we need to know about the blocks for now. Thanks for watching and see you in the next video. Hello again. In this video, we will see an application on SolidWorks blocks. We can relate SolidWorks blocks to kinematics and mechanism simulation. Previously, we tried to simulate two mechanisms, and it's obvious that when you have a lot of relations in your sketch, then the simulation becomes harder. In this part, we will create some mechanical mechanisms using SolidWorks blocks. Let's start with a sketch on the front. Draw a rectangle with the following dimensions. Now, once you create this, select it and select Make Block. Then hit OK. And now we have the first block. Notice that when you try to move a block, it's easier than moving a sketch with relations and dimensions. Then draw a circle and give it the following diameter, and once again select it and make a new block. Now select this block, hold Ctrl and select this one, and here we have a new relation, Engage Blocks. Think about this as applying friction between two bodies. Now we need this block to be horizontal all the time, so select this line and set it to be horizontal. Now this line will always be horizontal. Let's try to drag this. We cannot see the rotation here, that's why we need to edit this block and simply draw a center line here. Now finish editing the block, and now try to move this rectangle. As you can see, this circle rotates. In this way, we may represent rack and pinion gears. Now, we don't want this to keep going up and down all the time. That's why you can select this point, hold Ctrl with the origin, and then make horizontal. And now you can drag it this way. Let's insert this block again. Select Insert, and then select Block 2, and here you have it. And now we need to relate this block to this one. To do so, select both of them, and select Engage Blocks. Now, if you try to rotate this one, it will rotate, or if you try to drag this, it will drag it and both of them will rotate. But here, this one is not fixed. That's why we can select this point and set it to be fixed. This point won't move now. Try to drag this. And as you can see, this one was fixed all the time. Draw another circle. And draw a center line here. And define this as a new block. And now select this block and this one, and then engage blocks. Then set this point with this point to be horizontal. Now, when you drag this, all of them will rotate. Insert the second block again and place it somewhere here, and then make these horizontal and then engage them. And let's see what happens. Now, in SolidWorks blocks, we can define a build from here. So, let's insert the second block, one here, and let's say one here. Now, fix these 3 points. Make fix. Try to rotate this one. It rotates, but it's not connected to anything else. Now when you select belt or chain, you simply select this one, and they are connected by a belt, and select this one. Now you can reverse the direction of this belt, like in this case, or in this case, or in this case. Keep it this way, then hit OK. Now let's try to move any of them. As you can see, all of them are connected now. Select belt again, and this time select this one. Make sure not to select it from here, because in this case it will select the belt itself. So click here and then click here and hit OK. And now let's move this, and the whole system moves. Now let's select this block, right click and edit block. Select point and insert a point somewhere here. Then hit OK and finish the editing. Now we have these points in all these blocks. Once you move one, the points will move too. Now pick a line and draw a line somewhere here, and set this point with this point to be vertical, and set a distance between them to be 33. Give this line a length of 60, and now select the line and select make block. We have another block now. We don't need this dimension, so just delete it. And for this point, we need to fix it. Select this point, not the line, and select make fix. Now select the line and this point and make coincident. And now let's try to move this and notice the motion of that line. If you try to simulate this without blocks, then you will need a lot of relations and a lot of dimensions, and you will not be able to achieve some connections like here. So using blocks is very useful when it comes to mechanism design, and it can help you to simulate the motion before you start the 3D modeling phase and the assembly. That's it for using SolidWorks blocks in kinematics. We saw how to connect many blocks together and how to create builds. Thanks for watching, and see you in the next video. Hello again. In this video, we will simulate this mechanism using SolidWorks sketch blocks. I'll start with a new sketch on the front, and then draw a circle and give it a diameter of 70 millimeters. Then draw another one here and let it be 30. Make these vertical, then set a distance between them of 170. Then draw a line and make sure to have a tangent on both sides, and the same one here. Now offset this one, reverse, and this one. Once done, trim entities and trim this part and trim this one. Finish this sketch. Make this closer and select all these, then select Make Block. Now we have the first block created. Then draw a straight slot, something like this. Let's go back and measure this circle. The diameter is 22. So now we need to set this to 11. And we need to set this to 250. Now offset the whole slot and set this value to 8. Then draw a center line and make sure to snap to the midpoint of this line here. Then offset again, and this time 12 and bidirectional. Now select trim and trim this line and this one. If you face this problem, drag these a little bit here and select this relation and hit delete. Then select fillet, set it to 20, one here and another one here. And now select all these, but make sure not to select this block with it. And then Make Block. Drag this. And now let's start with a center line. Draw a center line here and select offset. And let's go to evaluate and measure this distance. 24. So now go back here, select offset, 12, and then bidirectional and select this line. Then hit OK. And select offset again. Remove bidirectional, select this line. Hit OK and do it again and select this line. Then reverse the direction and hit OK. Now select this one and make it a new block. Now select this point and set it to be fixed, and select this line and set it to be vertical. After that, drag this a little bit here, select this line with this point and set them to be coincident, and set this point with the origin point to be coincident. Set this line to be horizontal and select this point with this line and make coincident. Now let's check the motion. As you can see, we have a problem here, and this is the advantage of using this method before going to the 3D environment. We need to increase this length. Now select this block, right click, then edit block, and for this dimension set it to be 300. And now we have a problem here because of the fillet. So select this point with this one and then make coincident. Then select this one with this one, make coincident, and redefine these relations here. Now set this line with this one to be equal, and that's it. And let's see the motion now. We still need to increase it a little bit, or simply we can reduce the length of this one. So now right click this block, and here instead of 170 let it be 140, and connect this circle to this one here. Then finish the block, and let's try the motion. Now it's correct. Then you will need to drag this a little bit down, so make sure to break the fix relation. Drag it here, and now select this point again and fix it. So this will be the frame. After that, insert block and insert this one once more, and insert again, and insert the frame once again. First of all, we need to rotate this one, so select the block, and from here select rotate entities and select this point, and for the rotation value let it be -90. Then the direction is correct, and then select this block and once again rotate entities, select this point, and then -90 again. Now drag this one a little bit here and set this block to be somewhere here. Set these points to be horizontal, and then select this line and make it horizontal too, and select this point and fix it. Now drag this here. Now select this line, hold Control and this one, and set them to be collinear, and this line with this point here and make coincident. Now grab this point and try to rotate this handle, and as you can see we have this motion now. So using this method you can simulate the motion before going to the 3D environment and starting the 3D modeling. You can select this block, and from here you can click and hold and you can see the motion. Finally, if you want to change the color of this sketch, finish the sketch and here right click and select sketch color. Then set the color you want, then hit OK, and now go back to the sketch and you can drag this handle and see the motion again. Thanks for watching and see you in the next video. Hello again. In this video we will talk about auto trace. Before we start, go to Options, select Add-ins, and from here go to SolidWorks Add-ins, and then you'll find auto trace. Select it, then hit OK. Now start a sketch on the front and type in here picture. Then open this picture. Let's say we want to draw lines over these lines here. In some cases it's easy and simple, but in other cases it's really complicated. So there's a very nice tool here in SolidWorks where you can trace these borders. If you select Next, you will find the Auto Trace dialog box. Here we have many options. Let's talk about them. So for the trace settings, we have 4 options. The first one is to use rectangular area. So simply select this, and as if you're drawing a rectangle. In this way, you tell this tool where to trace. So now, everything will be traced only inside this rectangle. Then select Begin Trace. Now, as you can see, it's not 100% accurate, but it gives you a base for your work. Now, you can change these options so you can see the difference in the results on the screen. The higher quality of the image you have, the higher quality of these lines. So this was the first option. The second option is freehand area. Select this option, click, hold, and just draw a border about what you want to trace. We have the same selection, then you can select Begin Trace. Then we have polygonal area. Click here, click here. Whenever you click, you create another line. Then you can close it and you can select it. And finally, we can pick the color. Select this one, and let's say we want to pick this color here. Once you select it, just select Begin Trace. And once again, you can change the options, and you can have different results. Let's go back to rectangle, and draw a rectangle here, and then Begin Trace. And let's see the results. Let's have something like this. I think this result is good. Finish it. And let me show you an example of how this method can be beneficial. I'll drag this here. And now I'll select this sketch and select Extrude. And we can have a 3D geometry out of this. Now you have the option to use that sketch directly, or simply you can modify that sketch. So if I choose all of these and set them to be a construction geometry, and now I'll select it again and I will set it to be fixed so it won't move, I can snap to it and use it in my new sketch. Like I can select spline, and now I can snap here, snap here. So when using a picture, you won't be able to snap to it, but using this method, you will have some reference lines and you can snap to them. You don't need to do all these for now. I just wanted to show you an example on how this can be beneficial. This completes this section of this training course. Thanks for watching and see you in the next video. Hello again. In this video we will talk about over-defined sketches. For now, start a sketch on the top and draw a rectangle. Now, give it the following dimensions. It's very important to understand the relations we have. This line is horizontal. this one is horizontal too. These two lines are parallel. This line is vertical, and this one is vertical too, and they are parallel. This line with this line are perpendicular, and it's the same here, and here, and here. So now, let's do something. If we have this length, it's equal to this one. So there's no need to define a length here and a length here, because they are already equal. Now let's try to define the same length here. So pick Smart Dimension and select this line, then you will have this message. The first option says make this dimension driven, which means you will only be able just to see the dimension. You won't be able to modify it or to change it. And it will be driven from this dimension here. So let's go with the first option, hit OK. And as you can see, even the line thickness is not the same here. Now, change this dimension to 80. And see, this one was changed too. Now try to change it. You cannot change this one because it's a driven dimension now. Now let me delete this. And again, try to define this dimension. The second option says, leave this dimension driving. Select this option, then hit OK. And now we have an overdefined sketch, and they turned into yellow, which means the sketch is no longer fully defined or underdefined, now it's overdefined. To solve this problem, click here, and we will have this window. So let's go to Diagnose. Now SolidWorks tries to find solutions for this problem. So as you can see here, let's go with Manual Repair, and then you can see if you select vertical, so you will have this symbol here, horizontal, vertical again, horizontal here. So you can delete any of these relations, so the sketch will be fully defined again, or sometimes more than one relation. In our case, let's say we need to delete this dimension, so select delete. And now the sketch can now find a valid solution, which means it's a fully defined again. Now this line and this line are perpendicular. So what happens if we try to define them to be parallel? We'll have the same message again. Now no solution found, which means this sketch is overdefined. So click here and go to Diagnose. Then we have 9 valid solutions. But as you can see, some of them are not practical. They will change the shape. So I prefer always to go to Manual Repair. And here you can change this distance to solve the problem. But we know that the problem here is that these lines are not parallel. So let's delete this. Then hit OK. There's another way to do it if you know the problem. So select these lines again with Control, then select Make Parallel, and this time we have these relations in red, which means they are the ones that they cause the problem. So just select this relation and then hit Delete on the keyboard. Now delete this dimension and set these to be equal, and draw an arc here, and this time set this to be coincident or midpoint. Both are the same. Now since this is half a circle, we have a tangent here and we have a tangent here, and the radius is 25. So there's no point of defining the radius here, but what happens if we define this radius? And then let's define another relation. Let's say these two lines to be perpendicular. Now we have two problems, not one. So select here, go to Diagnose, then let's say the first thing is that the perpendicular and you have 3 solutions. But as we said, I don't recommend these because sometimes they change the geometry, and it's very important to understand the problem. So go to manual repair. The first problem is that perpendicular. As you can tell here, we have this symbol and this symbol. So these lines obviously parallel and not perpendicular. So this is the first problem. Let's delete it. Now hit OK. And this dimension was converted to driven from the beginning. So again now, let's see the case when we have 2 problems. Delete this dimension, place it here, and then leave this dimension driving. And then let's set these. Let's set these to be perpendicular, then OK. Now, let's say diagnose and go to manual repair. Now, the equality here is a problem. The midpoint relation is a problem, but the biggest problem is the perpendicular, because obviously these lines are parallel. So delete this, then hit OK. But as you can see, we still have another problem. So now, go back here, manual repair, and what can we do? We have this distance, or we have this radius. If you define a radius, this will be inflected on this length, so it's enough to define a radius. So you need to delete one of them. So for now, I will delete this distance. Then hit OK. The last thing is that it's not important all the time to run the diagnose thing. Define it again here and leave this dimension driving. Now, when you come here, it's not important to diagnose, but it will give you like a general idea about the problem. You can directly go to manual repair and see the relations, or if you know the problem, you can simply solve it here without opening this from the origin. It's very important to understand what over-defines your sketch so you can solve the problem easily. Thanks for watching and see you in the next video.